What is matter? No, not what's the matter. I know you're doing fantastic since you're watching this. I meant, what is matter?
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
Matter is everywhere. It makes up this, this, and this. Everything's matter. Even you are made of matter. Because you matter. Matter is any substance that has mass and volume. In other words, anything that has weight and takes up space. There are 3 different types of matter. Solid, liquid, and gas. Now, what exactly is a solid? Solids come in all sorts of shapes and sizes. But normally, solids cannot change shape. This is because the molecules that make up a solid are frozen in place. But if we were to take a look at a solid through a really magnified microscope, one so small that we could see the molecules, it would look a little something like this. As you can see, the molecules are packed together in neat little rows. This means that although the molecules can vibrate, they cannot move past each other. This means that the solid cannot be compressed. Liquids are different from solids because the space they take up or the volume they occupy take the shape of its container. Although liquids don't have a specific shape, they have a distinct volume. If I try to pick up water, it slips right through my hand, since it is able to flow. A liquid also can't be compressed, since their molecules are still pretty close together. However, they don't stay in the same place like solids do. Liquids can slide or flow past each other. Out of the 3 states of matter, gases have the most energy. Their molecules move at high speeds, which allows gases to expand freely, filling the shape of its container. Gases don't have a fixed shape or volume. Since the molecules are so far apart, they can be easily compressed.
Matter is anything that takes up space now. And matter can be big or small, it's all over the place now. Matter can be something you feel or something you see. Or it can be invisible like the air that you breathe. Matter is everywhere.
Now that we know what is matter, what isn't matter?
So not everything is matter? You lied to us?
Well, you see, although there are a lot of things that are matter, there are also a lot of things we see and use every day that aren't in fact matter.
Is light matter?
Nope.
Is sound matter?
Nope.
What about fire?
Nope.
What about emotions?
Nope.
How about time?
Nope. Matter must have atoms and take up space or volume. You can't always trust your senses to identify matter though. Only smell and taste are reliable because they detect chemical compounds. Let's take fire for example. Fire isn't a solid, liquid, or gas, and it isn't matter. It is actually a process involving matter and energy. Matter is involved since fire is the result of the combustion reaction between oxygen gas, which is matter, and the substance being burned, such as methane gas, which is also matter. The many different components of fire itself are not matter. The light produced by the flames and the heat produced are energy, not matter. The flames you see from the fire are the result of an oxidizing chemical reaction that releases heat and light.
Oh, hi, didn't see you there. Oh, I wasn't talking to you. I was talking to the invisible gas. We all know that gas is matter. To be defined as matter, it must have volume and have mass. But how can we actually show that gas has mass? For today's experiment, we will be needing a beaker filled with some vinegar, some paper bags on the end of a stick, like this, and some baking soda. As you can see, we are taking vinegar, baking soda, or sodium bicarbonate, and this results in a reaction that produces sodium acetate, water, and carbon dioxide, which is our invisible gas. You can't see it, but it's actually there. Look, the carbon dioxide, the invisible gas, is filling the bag, which weighs it down. This is because carbon dioxide is denser than air. Now you know that gas actually has mass.
Hi, welcome back to Cooking with Carrie. Today, we'll be making my grandma's famous fried ice. To start, we'll need a stove and a frying pan. Turn up the heat to high heat, then add your main and only ingredient, ice. The ice is a solid, meaning its molecules are packed together tightly and vibrate due to their low energy. When we heat them up, like we are in the pan, the molecules get more energy and vibrate more rapidly. Eventually, the ice changes states from a solid into a liquid. This particular change of state is called melting. Our fried ice is almost done. As you can see, the liquefied ice, or water, is turning into water vapor. It is changing states once again, but this time from liquid to gas. The liquid's molecules move more rapidly as the pan continues to heat up, and once it reaches a certain temperature, the molecules move so quickly that they can no longer stick together. This is what happens when you see steam. Our fried ice is done. Here is the final result. Delicious! Let's see what our audience thinks of the dish.
There's nothing on the plate?
Am I missing something here?
Hey, look at this! This is matter!
Welcome back to your local news. Joining us today is Dr. Laura Wang, a renowned chemist in the philosophy of chemistry.
Thank you, Carrie. Matter has all sorts of cool characteristics. Not only are solids, liquids, and gases different from each other in their own unique ways, but there are characteristic differences between each type of each state of matter. We scientists call these characteristic differences properties. These properties help us to describe the chemical and physical qualities of matter. Examples of these descriptive qualities are color, boiling point and melting point, luster, malleability, and more. One property of solids is its solubility. This is a chemical property that refers to how well a substance dissolves in an aqueous solution, which is just our science way of saying something dissolved in water. Let's take salt, for example. It is very soluble and dissolves completely in water. Look, we can't see the salt because it has completely been dissolved in the solution. On the other end of the spectrum, a solid like flour is considered insoluble, as it does not dissolve in water. Although learning about matter may seem simple at first, there are actually many layers to studying them. By studying the different properties of matter, us scientists can discover new things about the world and uncover the hidden mysteries of this universe.
Thanks for joining us tonight, Laura. Now, back to your regular programming.
Hello, I'm Bob Ross, and I'd like to welcome you to the first Joy of Painting Chemistry Edition series. As usual, allow me to extend a personal invitation to all the viewers to get your brushes and your paints and paint along with us. Now, with the introductions out of the way, let's get started. Today, I'll be using an 18 by 24 inch double primed pre-stretched canvas, but you can use whatever you have available. So I thought we'd start off today with a simple little molecule that I hope you'll enjoy. Now let's start with a touch of the cobalt blue, and just to load a little bit onto the bristles. Pull the paint out and tap the bristles firmly to ensure a nice even distribution of paint. And let's go right about here. We're gonna make a nice outline of a circle, and we're just gonna fill that one in. This will be our first atom, more specifically of hydrogen. And we're gonna go ahead and change the color of the paint we're using. And beat the devil out of it. Now I'm gonna go up to the left of the molecule and just give it a little line using the carbon black. This is what you call a bond, you see. It's what attaches atoms to each other. This allows molecules to form. It's also there because everyone deserves a friend. Okay, now we'll go right into the bromine red. I really like bromine red. It's a very, very warm red. It's very nice. Once again, just tap a little color into it. Now let's go up to the end of the bond and give this hydrogen a little friend. As I like to say, there's nothing wrong with having a tree as a friend. Well, in this case, it's an oxygen atom. We want this oxygen to be a little bigger than the hydrogen, but if it's not, don't worry about it. We don't make mistakes, we make happy accidents. Now, for this other side, we're going to go back to our cobalt blue and give our oxygen another hydrogen friend. It's always good to have others you can rely on now, isn't it? So what we want to do is just paint this on the other side, get it nice and symmetrical, just like that. So once you've got that done, we can take a little bit of that carbon black. Let me just get some of that on the bristles to connect the two atoms, just like so. Now for our finishing touches, we're just going to give the oxygen a few little electron buddies. Using fluorine yellow, we're going to add 4 dots just above the oxygen atom. So 2 over here, and 2 over here. And that's it. What we have here is an H2O molecule, or more commonly known as water, one of the most common liquids on Earth. So with that, we'll be ending our segment here. Thank you for joining me today on another episode of The Joy of Painting.
Good morning, class. Let's start off today's lesson with a question. What do you guys know about matter?
Oh, I know. Matter is all around us.
There's solids, liquids, and gases.
Wait, that means there's 5 states of matter.
Actually, Eric, you're correct. In fact, there are 5 states of matter. We already know 3, solids, liquids, and gases. The 4th and 5th states are plasma and the Bose-Einstein condensate. To put it simply, plasma is an ionized gas. What is that, you may ask? Well, an ionized gas is a gas into which sufficient amounts of energy are added to allow the electrons of the gaseous molecule or atom to break free from the nucleus, yet still travel within it. In this state, both ions and electrons may coexist, but after a plasma is created, it no longer behaves like a gas. It now has electrical properties and a magnetic field. emitting forms of electromagnetic radiation such as light.
Wow, that's so cool. But I for sure never seen plasma.
Me neither.
So what makes it matter?
Good question, Laura. Even though you may have never realized, plasma is all around us. In fact, the most large and in-change example of plasma around is the sun. That's right, the sun's extremely high temperatures separate electrons from the nuclei of the myriad of hydrogen and helium molecules comprising the sun. In turn, you see the light energy emitted by the plasma. This is why all stars emit light. They are all made of plasma. Everyone got it? Let's move on to the fifth state of matter then, the Bose-Einstein condensate.
Ooh.
We would see Bose-Einstein condensate when temperatures reach super close to absolute zero, or negative 273 degrees Celsius. It is made by cooling a gas that has an extremely low density at ultra low temperatures.
What happens to the molecules then?
Since the temperature is so low, the particles also have very low energy. All particles have energy, and its state of matter depends on how much energy it has. If you think about a solid, the amount of energy the particles have only allows it to vibrate in a fixed spot. Therefore, if you take enough energy away from a group of atoms so that you have the smallest, tiniest amount of energy possible, we get the Bose-Einstein condensate. They are hardly moving at all, and the atoms clump together, entering the same energy states. From a physical point of view, the clump of atoms become identical, and the whole group starts behaving as though it were a single atom. Oh, would you look at the time? That's all the time we have for today's class. See you next time, kids.
Someone gotta prove it to you, someone needs to flow, what you gotta do to get it through to you, it's simple food, quantitative equivalent to one another, so the vortices rotating infinitely atoms in the same atom, decimated more than ever, demonstrating how to give an adolescent audience a feeling like what you're never fitting, and another entropy for error is until the day I'm gonna get a B falls, it'll be a plenty, cause another way to get it.